This video came in from one of you out there asking me to help you graph y equals x to the power of y, which is a difficult problem to graph for first purposes because this is an implicit function. This is an implicit equation, okay? Meaning we got y on both sides of the equation. So step one before you're graphing this thing, you've got to set this equal to x. So we got to figure out a way to get rid of this y value up here as an exponent. So I'm going to show you how I would start the problem by doing that. And once we get this set equal to x, then we can start playing around with some stuff and getting some points and start graphing it. But realistically, this type of a function is something you're just going to plug into a graphing calculator like Desmos online or a graphing calculator that you have in your classroom. But if you are being asked to graph it yourself, you're capable, we can do it. It's just going to be a really difficult graph to plot out on a piece of paper. So here we go. All right, we got y equals x to the power of y. We got to get rid of this exponent. So how are we going to do that? One trick we could do is we could raise both sides of this equation to the power of 1 over y. And I'll show you what that does here in a second. So if I put y to the power of 1 over y, I need to also raise the right side to the power of 1 over y. Our power over a power rule tells us we need to multiply these exponents together. And when we multiply y times 1 over y, you're going to get x to the y over y. Well, I'll show you why that's important in just a second. Over here we have y to the power of 1 over y. Okay, now think about what y over y really means. Anything divided by itself equals 1. So now what we've really done is we've broken this down to x to the power of 1, which is no different than just x. Hey, look at that. X is now all alone and isolated on the right side. Okay, so now we know x is equal to y to the power of 1 over y. So what that allows us to do now is pick values for y, and then we can plug that information in and find our x values, okay? It's an inverse here. So what we're doing is we're going to say, let's go y values. We'll just go 1, we'll go 2. Might as well throw 0 in there too. So we'll start with 0. We'll go 1, we'll go 2, we'll go 3, we'll go 4, we'll go 5. And then we'll just see what's happening. And once we get an idea of what's going on with the function, maybe we'll adjust these values, but I don't really know until we see it. Okay, so let's take value of y is 0. That would be equal to 0 to the power of 1 over 0. Okay, so can we take 0 like that, like we have here, and 1 divided by 0, if we type that on our calculators, we all know we're going to get an error. So that is not going to be a point of contention. We're not going to be able to plug that in. Okay, so let's just erase 0 in this case. We're not going to be using it. We'll use 1, throw 1 in for y, so that's equal to 1 to the power of 1 over 1. Notice these two 1s are replacing my y's because my y value in this case is a 1. So what's 1 to the power of 1 over 1? Well, that just equals 1. So that means my x value, because x is equal to this, my x value would be 1 for that. So 1, 1, hey, we got ourselves our first point. 1, 1. That's not going to be difficult to graph at all. Ooh, maybe this will be easier than I thought. All right, so next, let's plug 2 in. 2 is going to go in place of y and the other y. So what that would look like is 2 to the power of 1 over 2. Okay, this is where you're going to start grabbing your calculators, because if you're putting it at the power of 1/2, 0.5, you're going to get a decimal that's going to go forever and ever here. So let's just take a look. We got 2 to the power of 0.5 equals, and you'll see you're just going to get a value like that on your calculator. I would personally, I'm going to just break that down to the nearest hundredth. So that's 1.41. That's equal to 1.41 for my x. Okay, so what that means is this is my x value, this is my y value. So I'm going to go over here, I'm going to say when x is 1.41, our y value is a 2. Okay, next, now we go and we plug 3 in for y. So 3 to the power of 1/3, right? So that's 3 to the power of 1/3. Okay, when you're going to put 1/3 in as an exponent into your calculator, you're not going to put 0.3 repeating forever and ever and ever. So you got to put it in as a fraction. Make sure when you put 1/3 in as a fraction, you've got to put parentheses around that so it takes care of that first. So 3 to the power of 1/3. I'll show you what that should look like on your calculators. You got to group the 1/3 together. You got to get the 1/3 in grouping symbols. Hit enter, and I got 1.44 this time. Actually, it would be rounded to 1.44. Okay, so 1.44 is what I get there for x. Okay, so my x value is 1.44 when my y value is 3. So go over here. Let's list out another coordinate, 1.443. Looks like we're growing x values while we're growing y values. Okay. Next we go to 4, which is going to be equal to 4 to the power of 1/4. 4 is equal to the power of 4 to the 1/4. Well, 1/4, you can write that down as a decimal and cut it off early because it's just 0.25. So 4 to the power of 0.25. No need to put it in as a fraction with grouping symbols. And looky there. I think we've seen that number before, 1.4142. 1.4. I think this one came out to that too. Okay, so that's 1.41. These could be the exact same values. I'd have to go back and double check those. Okay, that could mean something later on. 5 to the power of 1/5. And we're just going to go down the list here and see what we're getting. So it looks like we were rising and then we started dropping. So that's interesting. Okay, 5 to the power of 1/5. Well, 1/5 is 0.2. So I'm going to say 5 to the power of 0.2 or 2/10. And I get 1.379. Okay, so that's going to just round to 1.38. I can go back over here. I forgot to copy that one down, so let's make sure we do both. We got 1.41 gives us 4 for y. We also have 1.38 giving us 5 for y. And then let's just do a quick big jump. Let's find out what our x value is when y is 10. So I'm just going to jump from 5 to 10 to see if I think what's happening is actually happening. Because it looks like we're rising, and then we're dropping. So we're actually going back towards the, let me make sure I understand that right. We're going back towards the, we're going back towards the y-axis on this. So this is going to like curve out and then back in. Okay, so that'll be an interesting function when we're done with it. Okay, last one, 10. Let's do 10 to the power of 1/10. Remember, 10 is my y value, so I'm plugging it in for y here and y here. So that's 10 to the power of 1/10. 1/10 just being 0.1, so you can plug that into your calculator. 10 to the power of 0.1 gives me 1.25, so 258. So let's round that up to 1.26. 1.26. Now, why am I rounding these just to the 100th? Honestly, just for my mental capacity. Graphing this is not going to be enjoyable. As you can see, my x values are so dang close together. So I can't really show a lot going out on the x-axis. To make sense of this, my x-axis really, if you look at these x values, 1, 1.41, 1.44, 1.41, 1.38, 1.26, I'm going to have my point of origin 0, and then realistically, I'm only going to be going to like 1 and 2 on this x-axis. My x-axis is not going to go very far out. Now my y-axis, it looks like it can rise quite a ways up if I go to graph this to give a decent idea of what this shape is going to look like. So I'm going to leave this here. I'm going to erase some of this stuff over here. I'm going to create a graph, and then we'll do is we'll plot these points and get an idea of what this equation actually looks like if we were to plug it into Desmos. All right, give me a second real quick, and I'll get that for you. All right, now we have a graph with an x and a y axis. Here we have a bunch of points that we can plot. So let's just start with the obvious one of 1, 1. So I'm going to go 1 over, 1 up. Plug that dot down. 1.41, 2. 1.41. So I'm going to mark halfway between 1 and 2. That's my 1.5, obviously. 1.41 is going to be a little to the left of 1.5. And that's going to take me up to 2. So let's put it right about there. By no means is this perfect. I'm doing it on a whiteboard. So graph paper would be ideal, obviously, and could save you a lot of struggle. 1.44 is quite a bit closer to 1.5. So I'm just going to go slightly to the right, up to 3. And then we're going to go back to 1.41 for 4. So 4 is right here, back to that same vertical line of this other dot. These two should be right above one another. 1.38 is slightly to the left of 1.41. I'm looking at that as 1.41, right? So 1.38, just slightly to the left, and that takes us up to 5. And then we got 1.26, which is just to the right of a quarter of the way away from 1, and that's going to be 6. So that's going to take me up, or no, excuse me, that's going to be 10. Okay, that gives me 10. So that jumps me all the way up here to 10. And this gives you a general idea of what your function is going to look like. Okay, kind of an awkward looking function. The person that asked me the question about making this video, they said it kind of comes out like a fish hook. I see exactly what you're talking about now. Okay, I love fishing, so let's go get some bass, huh? All right, so basically what I would say about a problem like this isn't something you're realistically going to be graphing on a piece of paper. If your teacher's asking you to do that, obviously it can be done, okay? But this is a type of function you're gonna plug into Desmos, use the tools, use the technology that we have out there available to us nowadays, take advantage of it, and you'll get that graphed out quick, and then you'll get an idea of it, and then you can work with that function from there using the technology we have available. Hopefully this makes sense. Study hard and good luck on your upcoming test.